Okay, here's number 5 on the chapter 3 quiz. Um, it's a z-score question. We have two babies. One's born with a gestation period of 32 to 35 weeks, and another is born after a gestation period of 40 weeks. Now, we can't really compare these two babies. I mean, I guess we can in absolute terms, but it doesn't make as much sense. One baby had more of a chance to, mature inside the mother's womb than the other one. So we know the average and standard deviation of babies born from 32 to 35 weeks, and we know the mean and standard deviation of babies born after 40 weeks. So we have a way that we can compare them with z-scores. Okay. And this is less obvious, but a good example might be, you know, who's more dominant, right? Serena Williams or Roger Federer, right? They didn't never actually play each other. They don't even play the same opponents, but you can ask, both of them have dominated their sport, the tennis, and but who has dominated it more, right? If you find, if you had an average, like if you're doing winning percentage, for example, you can find what the average ATP players winning percentage and the average female uh, tennis players winning percentage and the standard deviation for both of those, then you can really compare the two, even though they don't play the same opponents and don't play each other based on their Z scores. Okay, so this is the same kind of idea. It's a little less obvious that you can do that. It doesn't jump into your head right away, but that's exactly what we're going to do. So here's my work on that. For the baby that was born after, I think it was 33 weeks or something like that, in this gestation period, the average is 2,600 grams with a standard deviation of 600. To get the z-score for that baby, I take the baby's weight, 2,125. Notice that that's below average, right? Both of these babies are below average. Who's more below average is what we want to know. And subtract the mean and divide by the standard deviation to get a z-score of negative 0.79. We'd always expect that negative to occur when you're below average. Okay, and then we do it for the baby born after 40 weeks. So here the baby's weight is 2,725 grams. The average weight is 3,200, and we're dividing by the standard deviation to get a z-score of negative 1.01. Okay, now we would say that the z-score of this baby is lower, so that 40-week baby is actually more below average. And you can look at the two weights. The 40-week baby actually weighs more, but it's more below average for a gestation period of that long. Okay, so let's see if we can put that in. The baby born. So now we want to say the baby born in 40 weeks is relatively less, since the z-score negative 1.01 is smaller than the z-score of, I think it was negative 0.79. 101, yeah, and 79, yeah. For the baby born in week 33. So we're just going to check the answer. Okay. So I hope that helps clarify how you can use z-scores to compare things that aren't necessarily alike, as long as you know the mean and standard deviation of those two things. $69. There we go. So 69 is the first value that we would reject the null hypothesis again, right? So what do we say? It was, I believe it was 50 to 68. Those are the values that we do not reject the null hypothesis. So 50 to 68. Okay. Those are all the values for which we do not reject the null hypothesis. Anything lower than 50 and higher than 68%, we're going to reject the null hypothesis. And then it asks us to do to construct a confidence interval at 95%. Notice that this is 95%, and before our significance was at 5%. Those are complements of each other. So I can actually just do this, hit edit. So a confidence interval for 59 successes, 95%. And our lower limit would be 49%. I think it's, yeah, round to 3 places. So 494. And then our upper limit of our confidence interval is going to be 0.686. Okay. Now, what's really cool here, and the reason that this question is so valuable, is look at this, right? The lower bound is basically the same, almost the same as when you start rejecting the null hypothesis on the low end, and this upper bound is when you start, is basically when you start rejecting the null hypothesis on the upper end. And this is what connects hypothesis testing and confidence intervals, right? So I just drew a graph of this real quick. So for all these whole values, right, we do not reject in the middle here. And the null hypothesis was 59 right in the middle of this. My scale gets a little smaller here as I move to the right on the paper. As I was running out of room, I started doing the tick marks smaller. But that should be directly in the middle. The confidence interval at 95% is the same as the hypothesis testing at 5% significance. Okay, so that's really the connection between hypothesis testing and confidence intervals. The last question just says, suppose you change the level of significance in conducting the hypothesis test to 0.01. And I hope at this point you kind of realize after chapter 9 that the smaller you make the smaller you make the significance, right? The less you're going to reject things. The larger the do not reject thing, the larger this area of D's would be, right? Because you don't want to make a type 1 error of accidentally rejecting a good null hypothesis. Because of the connection between the confidence interval, that means that a 99% would be the same as a 99% confidence interval, right? So if we're not rejecting more things, then the confidence interval is going to be big. If there's more D's here in the middle, right? Like if the ends were to expand longer and these R's were to become D's and some of these R's too, our confidence interval becomes bigger. Okay, so what would it do to the range of values for P's, the point estimate in the first part? Well, more point estimates, right, would not be rejected. Would not make us reject the null hypothesis. So the range of values would increase because the corresponding confidence interval would increase in size. Okay. So both the area that we do not reject the null hypothesis and the confidence interval at 99%, right, would increase. So I hope that makes sense a little bit. This is a very conceptually deep question, but it connects two big themes in the class.